Welcome back, everyone. This week, we're going to talk about measures of position. Last week, we talked about the measures of center and measures of variation, right? So we talked about when you would use the mean and the median when you were discussing different types of data. And then we talked about the standard deviation and some other measurements of variation in data, but particularly the standard deviation. This week, we're going to talk about other positions in the data and other ways that we can talk about those relative positions, right? And ways to compare them. And we're going to talk about two real different styles, I guess you could say, or two different things we can do depending on whether or not the mean or the median would be the best measure of center. And so the idea is at first, when you collect some data, you would determine what's the best measure of center here. And then if you want to then talk about the data and answer other questions that aren't just about the measure of center, as you'll see here, then we would use one or the other method depending. For this week, we're just going to talk about the different ways to calculate these things and what they're all called. And you'll start to see how they're used as time goes along as we get further into the course. Primarily, we're going to talk about how to find quartiles and percentiles, both by hand and also in Excel, or at least the quartiles in Excel. We're going to talk about how to find z-scores, what they are, what they mean, and we'll do that towards the end. And then we're going to talk about what outliers are and how they relate to data and how you can kind of calculate whether you have some outliers in a data set or how you kind of know. So let's start with a data set where the median is the best measure of center. Okay, so let's say that we ask people about the income. This is the typical income at a particular company, right? Or what's the number of pets that you have at your home? These things might be best represented by a median because you could have outliers, right? You could have really large values. It's very easy for someone to make a lot of money at a company, very easy for a person to have a whole bunch of pets, right? And so these outliers can affect things like the mean. And so we would use the median in those cases. We can then discuss other points that aren't just the midpoint, right? So for example, remember the median is the middle of the data set. It's the data value that's in the middle, okay? It marks the 50% point for the data. So if we just have these 8 data points that you see over here, the median is 83.5. It is the 50% point of the data, right? 50% of the data is below the median, 50% of the data is above the median. That's always the case because that is what the median is. Right? It is the middle point of the data. So there's always 50% below and 50% above. Similarly, we can also split the lower half of the data and the upper half of the data. If we split the lower half, we call this the first quartile or Q1. Okay, and in this case, you can see it's going to be 67.5. But it is the midpoint of the lower half of the data, but it's the 25% point in the data. 25% is below that point, 75% is above. Similarly, Q3, or the third quartile, is the 75% point, and it splits the upper half of the data. Now, I have these slides here and these pictures here because if you want to do this in Excel, there's a quartile function, but it doesn't work right, not like what the problems will want you to do. It doesn't give you the right answers. If I try to explain what it does, it will be complicated. Rather, just use the median function, but only use the median function for the first half and the second half, right? So here we only have A5 through 8. That'll give us the median of the second half, right? And here we have A1 through 4, which is the median of the first half. Okay, so use the median function to calculate the quartiles in Excel. Okay, if you're going to use Excel to do it. If your data set's small, you can do this by hand very easily. If the data set has a whole bunch of data points, then it's much simpler to just use Excel to calculate it this way. So let's talk just a little bit more about this. We have ages of 12 mathematics teachers in a school district. We have all of these lined up in a row. If there are 12 of them, okay, we know the median is going to be the number in the middle, right? So it's going to be, if we take 33 and 41, add them together and divide by 2, that's 74 divided by 2, which is 37. And so this would be our median. And now to find the first quartile, or Q1, we're going to take the median of the first half. Okay, and to find Q3, we're going to take the median of the second half. Well, here if we find Q1, the median 27 plus 27 divided by 2 is just going to be 27. In Q3, we're going to take 42 plus 44 divided by 2, 86, which is 43. Oh, that would have been obvious as well. And so now we have the first quartile, right? So 25% of the data is below 27. 75% is above 27. We have the median where 50% is below and 50% is above. And then the third quartile where you have 75% below and 25% above. As we do with quartiles, breaking it down into 25%, 50%, 75%, we could do the same thing and break the whole data set down into 100 equal groups, 100%. Right? And so percentiles are just like quartiles and the median, right? In that they're just giving you a position in the data set relative to there's 10% below this point and 90% above, or there's 70% below and 30% above. Okay, so if sometimes you'll see it written with P with a little 10 below it. Okay, this implies then the 10th percentile. And so the 10th percentile just says that this is the point in the data where 10% is below that value. Okay, if you take a standardized test, right, and you score in the 70th percentile, it means that 70% of the scores that were on the test were below your score. Okay, this is a little bit of an older statement, but it's still kind of true. My daughter's in about the 30th percentile for height. She's very, very short. And so this means that about 70% of children her age are much taller than her, or taller than her. Okay, the percentile just gives you a position in the data set. Now, calculating percentiles can be a little strange, okay, and there's different ways to do this, and different ways to kind of understand how to do this. I'm going to show you this kind of direct way that I've learned that's somewhat helpful. If you do this a different way and still get the right answer, that's okay, it's probably fine. There's some slightly different formulas I've seen as well, but I'm going to show you this through an example. Okay, here we have data that's the population in thousands of a particular sample of cities. We want to find the 46th percentile in this data. And so we're going to use, well, the first thing is, the simplest thing is always just to put the data in order. That's going to be the easiest thing to do. So line everything up. And here you can see that I mentioned sorting in Excel. That is extremely helpful once you have all the data values in there. Now, the next step is to find this value C. Okay, and C is just a number we're going to use to find the position in our data set. Okay, it is the number of data points that we have. So in this case, 25 times the percentile that we're looking for divided by 100. Okay, so you can also look at this as 25 times 0.46. okay? And that'll give you 11.5. Now, here's where it's a little strange. If the number is not a whole number, okay, you round up, right? And so we're going to round up to 12 in this case. And so the 12th number in the data set, in this case 29. Okay, so 29 would be the 46th percentile. And that just means that 46% of the data is below this value of 29. And we can do the same thing with other data values if we just chose another percentile. Right, so let's say we want to find the let's say we want to find the 85th percentile. And so we would then find that value C, 85, or I'm sorry, it's not the best color to use either. There's 25 data points. We want the 85th percentile, so times 0.85. We can do it that way. Okay, 25 times 0.85, that is going to give us 21.25. Okay, it's not a whole number, so we're going to round up to the next value, which would be 22. And this would be our 85th percentile. If you wind up with getting a whole number here, the trick is then to do the same thing you would do with a median where there are an even number of values. You're just going to take the two numbers and divide to find the number in between. So this, in this case, would be 22. We can figure out what percentile that is. I think in another example, we're going to do something similar. A little bit of practice with this. And it should be, well, let's do this real quick. Let's find the 84th percentile. So I think that'll do what I want to show you. So 25 times 0.84, slightly different from 0.85. That should give us a whole number. $21. Now, since we have a whole number here, we're going to take the 21st number and the 22nd number, our number in the next one, so 21 and 22, add them up and divide by 2. So 49 plus 69 divided by 2. It's a little harder to do in my head. That'll give you 59. I probably could have still done that in my head. And so in this case, 59 is the 84th percentile. Okay, that means that 84% of the data is below 59. 85% of the data is below 69. Because there are less than 100 data points here, right, some of the percentiles will overlap, and that's okay. We can do something very similar here to find the 60th and the 65th percentile, right? So we have, I don't think it tells me how many data points we have here. Let's count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 3, so there are 45. Okay. 45 data points. If we want to find the 60th percentile, we're going to do 45 times 0.60. 45 times 0.6 is going to give us 27. Okay, so we want the 27th number and the 28th in the list. And so that's going to be, let's see, 27, if this is 15, 30, 29, 20, 27, and 28. We're going to add them up, 3.57 plus 3.71, divide by 2. Let's grab the calculator again real quick. 3.57 plus, not times, plus 3.71 divided by 2 gives us 3.64. And that'll be the 60th percentile, 3.64. If we want to find the 65th percentile, well, we'll do the same thing, 45 times 0.65. Now I don't believe we'll get a whole number, so the rest of it's a little bit easier. 45 times 0.65 was 29.25. Now remember, we round that up to 30, and so we want the 30th number in the data set, which would in this case be 4.27. With a little bit of practice, you guys will get the hang of this. If you have questions about it, you can always send me an email, and I'll be happy to help. Okay. If you're given the data value in the data set and you want to determine the percentile, well, then you've just got to count how many values are below it. And then you're going to use that to figure out its position in the data. Okay. So for example, if we want to find the percentile that corresponds to 25 here, okay, we're going to first find the number of values that are below 25, right? And so there are 23, there are 7 below 25. You're going to take that 7. The plus 0.5 is just to keep from having 0 as an answer at the bottom. It's just a little math trick. So that 0.5 doesn't really pertain to anything, but do add 0.5. Divide by 25, or divide by the number of values, in this case 25. Okay, and then multiply by 100 to get the percent. Okay, it'd be 0.3 before that. And so this is the 30th percentile. And because of the way that these values work, if you have 25 values, no matter what they are, the 8th number is always going to be the 30th percentile. Just like the 13th number will always be the median. Okay, regardless of what the values are, right? Because all you're doing is identifying its position relative to the other data points, right? So there's 30% below and 70% above. Okay, that's always true for the 8th data point in a data set when you put them in order, no matter what those data points are. There is another way that we can look at data, and it requires kind of understanding what's called the 5-number summary. The 5-number summary is just the minimum and the maximum values tossed in with the different quartiles and the median. And we're just going to list them all out like you kind of see here. But it's less useful as just a set of numbers, though you can look at them and kind of learn something about them. And it's more useful in what we're going to do with them. Right? We can use this 5-number summary to make a visualization, to make what's called a box plot. And that's what we're going to talk about next, or in just a minute. There's a few more things I realize that are coming up first. Okay. Just like we can talk about the range of a data set, so the maximum value minus the minimum value, right, as we talked about last week, we can talk about the interquartile range, which is the difference between the first and the third quartile. The interquartile range is used when you have outliers in a data set. Notice the range in these two data sets would be very different, okay? But the interquartile range would be exactly the same. And the data sets are almost exactly the same, except for the one outlier in the second one. Okay, and so it's helpful to use this range when we believe there are outliers in the data set. Okay. But again, this is also when you have things that are best represented by the median, right? We're still talking about those in general. Now, if we wanted to determine if there were outliers in a data set, right? So we collect a bunch of data. Is there anything that's going to behave kind of like an outlier, or anything we might want to think about we would consider as an outlier? Or in some cases, this is how Excel will calculate outliers. Okay, we can use the interquartile range and the first and third quartile. Okay, and we're just going to use that as multiplying any number that's more than 1.5 times the interquartile range away, below the first quartile or above the third quartile. We call those, we can call those outliers. In Excel, you'll see them in Boxplots as dots. They'll pop up as dots inside of the those different box plots. Okay, and then you'll see that we can kind of, I think we'll be able to do that with one of ours as well. So let's take a look then at the next. Okay, yeah, so we're going to talk about box plots in just a second. Outliers can be determined in lots of different ways. It can appear for lots of different reasons in different things. And in most general research, you would like to design your research so that you don't have to worry about outliers. But things can always occur, and so it's helpful to do this. It's also helpful to know how Excel is going to calculate those outliers as well. Now, the 5-number summary is important because it allows us to visualize, or it allows us to then make a visualization of the data. Okay, and we call that visualization a box plot. I'm going to show you a few of these, and we're going to go through and do a few of these as well. And I think that it's helpful to see how much information a box plot contains just from those 5 numbers in a particular shape. Okay, so this is what a box plot looks like, right? This is just from the sample data that I've been using in all of the other examples, the ones that you saw when I mentioned the 5-number summary. Okay, it is a visual representation of the 5-number summary. Okay, we have lines at the minimum, okay, the first quartile, the median, okay, and sometimes you might see this as Q2, the third quartile, okay, and the maximum. Okay, you should have a scale, right, on this side. There's going to be some type of measurement associated with what you're, putting in the box plot, and so you would put that here. Okay, you might see these sometimes horizontally rather than vertically. Excel, I think, defaults to doing them vertically. And so these are kind of what they look like. This value here in the middle is the mean. Okay, that is important if you want to compare the mean to the median. If you want to try to determine if data might be symmetric, you would expect the mean and median to be equal or close to equal. And so if the X and the middle line kind of sit on top of one another, then it's likely a symmetric data set, but you can also see that from the whiskers as well, right? We can see there's a lot. Remember, each point marks 25% of the data. Okay, so 25% of the data is above, or is from 96 to what appears to be 110 or something like that. Maybe it's 98 to 103 in this case. Okay, but that's really squeezed in compared to this whisker, which appears much longer, right? And so the data in the bottom 25% are more spread out than the data in the top 25%. And you can see that in all of the different portions of the box plot. Each portion of the box plot represents 25% of the data. And so we can do a little bit more with these. I'm going to show you how to construct a few of these. They're pretty simple to do. Okay, in this case, we have all of our values. Okay, and we have a scale. I'm going to show you this one horizontally. The idea of constructing a box plot is very simple. Right, we're just going to draw a line at the minimum. We're going to draw a line at every point. So let's start with the minimum, which is at 3, which would be about right here. Okay, Q1 is at 8.6, which is probably about right here. We're going to draw another line. The median then at 10.6, so just a little bit past it. Q3 is at 17.25. And then the maximum is at 37, so all the way over here. Okay, we're then going to take the middle three lines and connect them into a box. Okay, and then draw whiskers to the outer edges. And we have a box plot. Pretty straightforward, simple thing to do. And again, you can see, 25% of the data is well spread out here, and it's much less spread out over here. Right? And these are the types of things you can see in a box plot. And that's why they're useful representations of data. Now, this is not from the survey that you guys did in the first week of class, because I haven't had a chance to collect all that data, and there's still some, I'm not sure that there's quite enough, but it is from another class that I've had, okay, from the same survey. And I just asked them, how many TVs do you have? And here you can see the distribution of TVs in that particular class, right? We can see that there's 25% of those students who had 2 TVs or less, okay, 50% with 3 TVs or more, okay, and then 25% between 4 to 6 TVs, right, in their homes. And so it's a useful way of visualizing data, right? And those position representations give us an idea of ways to discuss the data, ways to talk about what the data tell us. And so here, if we want to find the 5-number summary for these 21 students, we first need to find the median and the first and third quartile. And so the median would be the number in the middle. So the 11th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's the median. Okay, now we're going to take the first half of the data, and we're going to find the median there. And that's going to be Q1, which in this case would be 65. Oops. Q1, which would be 65. Split the second half of the data, that'll give us Q3, which would be 87.5. 87 plus 88 divided by 2. Okay, and so now the 5-number summary, the minimum is 60, the maximum is 95. And so we can construct a box plot for that. I'm going to show that on the next slide. Let's just copy this stuff over. The minimum was 60. Okay, Q1 was, I believe, 65, and then 81. The median was 81. Q3 was 87.5, and then the max was 95. Okay, so we're just going to draw lines at those points. Let's draw a line at the minimum of 60. Okay, Q1 would be at 65. Okay, the median is at 81. Q3 is at 87.5, so about halfway here. And then the max is at 95, so all the way up here. We draw a box with our 3 values in the middle, and then connect them with whiskers to the outsides. And here's our box plot. You can see 25% of the data is here, 25%, 25%. I wrote that very badly, 25%, and so on. So let's take a look at one more example. Let's say we want to use the IQR method to calculate if there would be any outliers in this data set. First, we need to find the median and the first and third quartiles. Okay, we have 22 values here, which means the median is going to be halfway between the 2 in the middle. So think it'll be halfway between these two. But I feel like I'm miscounting. 11 is, yes, that's right. And so here the median is 51. If we want to split the bottom half of the data, the bottom 11 data values, okay, and the top 11 data values, and then we're going to find the value in the middle here. So there are 5 below. So here's Q1, and here's Q3. And that's what we need to find the interquartile range. 59, right? Q3 minus Q1. So 59 minus 45. And that's going to give us 15. And so now we can take, and if we want to determine if there are outliers, right? So if we had a really small value, it would be Q1 minus 1.5 times 15, times the interquartile range. 1.5 times 15. $22.5. So Q1 minus 22.5. That's 45 minus 22.5. That's 22.5. Okay. And there are no values in the data set that are below 41. So there's nothing that's below 22.5. So there's not an outlier there. Okay. If we then do the same thing, we're going to use Q3, but now we're looking for outliers above the third quartile, large values in the data. So Q3 is 59. Just gonna plus 1.5 times the interquartile range. That's still 22.5. So 59 plus 22.5. We'll give you 81.5. Okay, and now there are data values that are above 81.5. And so 100 would be considered an outlier here. Okay, it would be an outlier in our data set. And so let's look at how we would put that in a box plot. And I'm going to go to the next page to draw it again. I'm using the same scale as before. Just want to make sure I get these values here. 41, 45, 51. Minimum was 41. Q1 was 45. The median is 51. Q3 was 59. Okay, and then the max was 100. Okay. The next value below that was 77. And so keep that in mind. Here, if we want to draw a box plot for this example, run an account for that outlier that we found. And then we would draw, again, draw a line at 41. I don't have enough space here to do this. Let's kind of nudge those out a bit. Let's say this starts at 40. That'll work. Okay, so for the purposes of this, I'm going to draw a line at 40 or 41, thereabouts, about at 40. And one at about 45. One at about 51. Okay, one at about 59, so just really close to 60. Okay, and then the max is up here at 100. Right, and so our box looks like this. We know 100 is our is something we've identified as an outlier. And so Excel would plot that data point as a dot. Okay, and then what you would get is a line at the next highest point, the one that wasn't an outlier. Right, the highest point that's not an outlier based on that IQR method. And so our next line would be here at 77. We would connect the whiskers to the box this way. Okay, and then you can see the outlier compared to the rest of the data set. I'm going to pause here before I do the second half and just tell you guys about z-scores and things. Please let me know if you have any questions about making box plots or finding quartiles or percentiles or anything like that. We will talk again soon.